Now we're going to multiply monomials, and what we're going to do is realize that multiplication is commutative. That means like 3 times 4 is the same thing as 4 times 3, etc. So now let's go for it. So I'm going to do that first one. So it's 5x squared times x to the fourth. And this is really great because my two x's are next to each other. They're the same base, so I add my exponents, so I'll get 5x to the sixth. The next one is 2x squared y times 3x to the fifth y squared. So the deal on this is that I can move things around. See? I just moved everything around because the commutative property lets me do that because everything is under multiplication. Now I'm going to multiply 2 times 3 and get 6. X to the second times x to the fifth is x to the seventh because I really have 7 x's in total and 3 y's, y to the third. Done. So for this one, instead of moving things around, I'm going to kind of move them around in my mind and realize that I can multiply the coefficients together. 8 times 7 is 56. I have a total of 13 x's and a total of 5 y's. Now this next one requires you to use the distributive property. So what I'm going to do is I'm going to multiply 3x squared through by both of those terms. So it looks like this: 3x squared times x to the fourth plus 3x squared times x. And then we individually multiply those things to right here and right here. So it'll be 3x to the sixth plus 3x to the third. Done. So now we are going to multiply two binomials together. And we can use the FOIL method, which is first, outside, inside, last. I think to look at it as a double distribution is awesome as well. What we're going to do is we're going to take this t and multiply it by the entire t plus 5. And then we're going to take this negative 3 and also multiply it by the entire t plus 5. So it looks like this. T gets multiplied through. T times t is t squared. T times 5 is a positive 5t. Now we're going to multiply this entire negative 3 through here. So it's going to be a negative 3t. Negative 3 times a positive 5 is a negative 15. And then, of course, the last step is to combine like terms. So we're going to do that. The like terms are right in the middle here. So this is going to be t squared plus 2t minus 15. Notice how meticulous I am about putting the signs in front of each term. Next. The next one can be intimidating, but if you write out what it means, it will help you multiply it out. So this is really 2x plus y times 2x plus y. And then we're going to use the FOIL system. So 2x times 2x is 4x squared. 2x times y is a positive 2xy. Now let's do the inside terms. 2x times y is a positive 2xy. And then the last is a positive y squared. So now, again, we're going to combine the like terms in the middle. So we ultimately get 4x squared plus 4xy plus y squared. Recall again that a like term is the same variables raised to those exact same variable exponents. Next. Let's do some more multiplication using the FOIL method. So we're going to do x times x is x squared. X times a negative 3y is a negative 3xy. Now we'll do the second term through here. Pull it through. We get a positive 3xy. Yeah, we do. And 3y times a negative 3y is a negative 9y to the second. I think the hardest part about this is combining the fact that you're multiplying first and then combining like terms. So you have to kind of keep all of those rules straight. Now we're going to combine like terms in the middle, and I'm psyched because these two, negative 3xy and 3xy, will add out. So they're gone. So I write down x squared minus 9y squared. Boom ba. Next. Now, if I just write out what this means, I'm never going to miss a term. Let's distribute the x through to the second binomial. X squared minus 3x. Now let's do this guy. Yeah, let's. Negative 3x plus 9. Notice how the middle terms do not cancel in this case. I will get ultimately x squared minus 6x plus 9. Cool? On part C, these guys are called conjugates of one another. They're the same, but just the signs are opposite. These guys are just the same dudes, so that middle term is not going to cancel out. Now, what about these guys? What happens when we have things that are kind of insane? I'm going to show you a cool way to do 3a. I'm going to rewrite it as the vertical method. X plus 2. I love this method. So first we're going to multiply the 2 times the negative 1, which is a negative 2. 2 times 3x, which is a positive 6x. 2 times 3x squared is a positive 6x squared. Cool. Now we have to multiply the x through by everything. X times negative 1 is a negative 1x. Notice how I put it underneath the 6x because they're like. X times 3x is 3x squared, positive. And x times 3x squared is 3x cubed. Now I'm just going to add down negative 2, positive 5x, positive 9x squared, 3x cubed. Bada bing. Now, the next one is a little bit tricky. The first thing I'm going to do is keep the negative 2 outside, and I'm going to write out what this means. Because in order of operations, you always do exponents first. So I need to do that first, and then I'll distribute the negative 2 through. X times x is x squared. X times 3y is 3xy. 3y times x is 3xy. Notice how I put the x in front because I like everything in alphabetical order, can't help myself. And then 3y times 3y is a 9y squared. Let's combine like terms before I distribute that negative 2. 3xy plus 3xy is 6xy. And now I'm going to just distribute my negative 2 through. Negative 2x squared minus 12xy minus 18y squared. Done. Okay, now you can do the assignment associated with this lesson. Stay strong, do the math.